Hello, class, and welcome to Chapter 2, Section 7. We're now talking about the percent of change. So, in this chapter, we've talked all about solving different kinds of equations with a variable on both sides, single step, multi step, absolute value, and before we also talked about ratios and proportions. So, now we're going to talk about percent of change. So anything over 100 is percent per 100. So we'll talk about the way numbers change percent-wise, and we'll solve some problems using percentages. So some vocab to look out for. Percent of change, so it changes in some way. We also look at which direction does it change. Is it increasing or decreasing? And we'll see those as we work through some examples. So here's our first one for today. We're asked to determine whether the percent of change is an increase or a decrease. So these words here are vital to our understanding of what's going on. We have an increase or a decrease. So pay attention to the wording. Part of this section is going to be your ability to read word problems and understand what they're asking you. So increase or decrease, we can find the percent of change. So the original is what you start with. So if you start with 32 and you end with 40, did we increase or decrease? And that's what we need to think about. So if we start at 32 and we end at 40, we know we have now more than what we started with. How many more? Well, you could find the difference of those two through subtraction. So if you take 40, take away 32, you know you changed 8 units. And we already said if we started with a lower number and ended with a higher number, we increase. So it's going to be a percent of increase. And we increased 8 units. So if we take the percent, that's what we're interested in finding. We'll take the original number, which was 32. So if we go back, we started with 32. So we'll take that 32 as our base. Our original is our denominator. How much did we change? That's the numerator. So 8 over 32, the change over the original, must be equal to the percentage that we're going to find. So some percent, some number, over 100. 100%, percent per 100, so there we go. Per 100, whatever this number is going to be our percent value. And now look at what we have. We have our proportion, and we know how to solve these because we did many of these yesterday with our last section. So how do we solve this with a variable? We know we have to cross multiply. So knowing we cross multiply, we find those cross products. R times 32 is 32R. 8 times 100 is going to give us 800. And now with just a couple steps, we can get our variable by itself. So on the left, we get 800. On the right, we get 32R. And we could divide each side by 32. So we see that R should equal, if we plug that into a calculator, R should equal 25. So there we have that value. And that is example 1A. Find the cross products, set up your proportion, and solve for your variable. It increased by 25%. And they didn't give us units or any context, which is okay. They just gave us numbers, but we'll see some context later on in some other problems. So here's another one. We want to think about these numbers. Starting with 20, we ended with 4 of something. We don't know what. But we started with 20, we end with 4. Is that an increase or a decrease? So first, let's think about that. Well, if you start with 20 and you end with 4, you definitely have less here than with what you started with. So we know that it has to be a decrease. We're talking about some kind of decrease. But now we need to find the percent of change. So in order to find this percent of change, we need to set up a proportion. And our proportion is going to be our change so the amount we change over our original value. I'll just put origin. So change over our original is going to be equal to our percent change, use any letter, R works, over 100. Because we're talking about percent, that's per 100. So the change over the original will equal our missing percent of change over 100. So now we can just plug in the numbers that we know. How much did it change? Well, to find that, if we start with 20, we end with 4. How much did it change? Well, that's just 20 minus 4, which we know is 16. So the change is going to be 16. That's going to go there. Our original value we know is 20, so that's going to go on the bottom here. And then we have 3 numbers and 1 variable, and we know how to solve those. So all we have to do is plug those in. So we said the amount of change is 16. We found that here. Our original number was 20. That's going to be the base. So if we plug in, like we were saying, change, 16. Original, 20. 16 over 20 is going to be equal to our percent that we're going to find. So the percent of change, some letter, we don't know, over 100. And now we're back to an easy proportion. Find those cross products and solve for your variable. So 16 times 100 is going to be equal to 20 times R. We found those cross products. Now with just 1 or 2 steps, we can solve this. So 16 times 100, add 2 zeros, 1600. And 20 times R is just 20R. Now this R and this 20 are tied by multiplication. So to get R alone, we have to divide by 20. So divide both sides by 20, and we get 80 equals R. So in other words, our percent of change is 80%. And that makes sense because we started with 20, we ended with only 4, so it changed a lot, almost 100%, a little bit less than that. So we see here our percent of change, 80%, that makes sense. So we're good to go on this example. So here's 1C. Let's first answer the question, is it an increase or a decrease? So if I start with 20 and I end with 18, did I go up or down? Well, I know that I went down. So I'm talking about some kind of a decrease. So I know right away A is wrong and C is wrong. Those are increases. It says find the percent of change. So I know my percent of change is going to be, my original number will be here. So that's 20. My amount of change will be my numerator. So from 20 to 18, how much did I change? If I subtract these two, I know I get a value of 2. So change 2 units. Change over original is equal to my percent change that I have to find over 100. So if we do a cross product here, 20 times R and 2 times 100, I know 200 equals 20R. And I know that here my variable is R. I need to get it alone. How do I get R by itself? If it's tied to a number by multiplication, well, I have to divide that thing away. What do I divide by? This number. I need to get rid of it. So divide both sides by 20. 20 over 20 goes away. That's just 1. It cancels out. And on the left, 200 divided by 20 is an easy number. You can check this in a calculator. 10. So 10 equals our variable R. We've got it all by itself. We solve for that, and this is going to be our percentage. This is our percent change. So R is 10%. So do we see a decrease of 10% as a possible answer? Yes, we do. That's answer choice B. And that makes sense because it only changed a little bit from 20 to 18. A decrease of 90% would be a huge, huge decrease. So 10%, small decrease, that makes sense. So for 1C, just a couple steps, our answer should be letter choice B. So have that one down. 1D, same process. So first, are we going up or down? Is it an increase or a decrease? If we start at 12 and we end at 48, clearly we went up. We increased a large amount. So we know we have an increase. Now we need to find the percent of change by setting up that proportion. So same process. I know on the right I'm going to have some percent over 100. We don't know what R is yet. We have to find it. On the left, I'm going to put my original as the base, 12, and my change on the top. So how much did we change from 12 to 48? Well, we can just subtract the difference between these two, and I'll start with a bigger number. So I know I'll end up with a positive. So 48 minus 12 is 36. So 36 is the amount we change from 12 to 48. Change over original equals R over 100. And now we're back to cross multiplying. So we'll do 12 times R. We all know this very well by now. And 36 times 100. So 12 times R equals 36 times 100. Just add 2 zeros. So that's 3,600. And now we remember our goal is always to get our variable alone when we want to solve for it. So there's R. This 12 is in the way. We don't want that. It's tied by multiplication. So to get rid of multiplication, we have to do the opposite. So we divide. We divide by 12. Whatever we do here, we have to do on the other side as well. So 12 over 12 goes away. That's just 1 R. So we get R on the left. And on the right, 3,600 divided by 12. Let's think about what that is. If we forget the zeros for a second, 36 over 12 is what number? How many times does 12 go into 36? Well, it goes in 3 times. So 3 would be this, and then we add 2 zeros. So R, and you can check this in a calculator, R will equal 300. And remember that R is always a percentage. So our percent of change is an increase. So we know those are wrong. It's an increase of 300%. So do we see that as an answer choice? Yes, we do. That has to be answer choice A. Just a few steps and we solve it. Now here's a real world example. So at a store, the price of a pair of jeans is $26. So I'll circle that, that's important. At another store, the same pair of jeans has a price that is 22% higher. So what's the price of jeans at the second store? So what we need to do here is find out what is 22% of $26. So we need to do some multiplication here. So 0.22 is 22% as a decimal. And if I multiply 0.22 or 22% times my original value, $26, that's going to tell me what the increase is. This percent increase, what that is in dollars. So 22% of $26 is going to give me what? Well, we can check this in a calculator. And $26 times 0.22 should be $5.72. So that's the extra 22% difference at the other store. It's more expensive at this store. So this is that 22% increase. Now we want to answer the question, what is the price of jeans at this second store? So in other words, if we start with an original, $26, and the other store charges $5.72 more, what is the price at this more expensive store for those same pair of jeans? Well, all we have to do is add these together. 26 plus 572. So our total should be $31.72. So there we see that answer. How did we get this? We used the percentage, made it a decimal, multiplied by the original. We found the change, and then we added to the original. So if we think about what's happening here, we can eliminate an answer or two right away. So we know 22% higher means it'll be more than 26. So we know 25 is already wrong. That's lower. And then we only have 3 left, and we already said, based on those steps, it's got to be $31.72. So for this example 2, your solution is B, a little under $32. Now our third type of example for today is about sales tax. So sales tax is what states charge whenever you buy something. Okay, so in this case, the sales tax is 5%. Now, it differs in different locations, but for this example, we'll just say it's 5%. So 5% is our sales tax. A meal for 2 at this restaurant is $32.75. Now, the sales tax is an additional fee on top of whatever the restaurant or business charges you to have their product. So $32.75 plus 5% of that is going to be our total price. So what we need to know is, what is 5% of this number? How do we find that? Well, we need to turn 5% into a decimal. So 5%, if you think about it, percent just means over 100. So 5 divided by 100 is the same thing as 0. Just move your decimal over to 0.05. So all you have to do to move a percentage into a decimal, move the decimal over 2 units. So 5%, 0.05. So we'll take that 0.05 and multiply that by our original value, $32.75. And that's going to tell us how much more we have to pay for sales tax. If we multiply that out using a calculator, or you can do it longhand, we get 1.6375. So roughly $1.64 is what you would have to pay in addition to this $32.75. So now our last step, what's the total price? We'll take the original plus this new sales tax, add those together, and we get that final amount for what we would have to pay. So we round that up to 164, and we add that to the original price. So $32.75 plus 164 gives us $34.39. So our answer for this one using sales tax is an increase, $34.39. That's the total price of this meal. So 3B, similar type problem. We're talking about sales tax added to a purchase. So a portable CD player originally is $69.99, but we have to pay an additional 6.75% tax. So what we need to know is, what are we going to actually have to pay? What's the total price when we go to make this purchase? So we know the total price has to be greater than this $69.99 because this tax is an increase in what we owe. So I look right away, I know 64 is a decrease, so that has to be wrong. Now the other 3 go up, so they could potentially be correct. So let's think about what's happening here. We need to find out what is 6.75% of $69.99. Well, to find that, we need to turn this 6.75 into a decimal. And I already told you to do that, you move the decimal over 2 units. So you can move it over once and get 0.675, and twice would give us 0.0675. So 0.0675 times our original value, this is going to give us a small change, a small amount, a few dollars increase in our sales tax. And then to whatever that is, we'll add what our original price is. So let's break down what's happening in this equation. So this first piece here is just the sales tax. This is the amount we have to pay in addition to the original. That's just the tax, this 6.75%, just the tax. This is, of course, what the store is charging us for the product that we're buying. This is just the original price of the item. I'll just put original. So with the original plus the sales tax, we'll get our final answer. So you can plug this into a calculator and get that value. Okay? I know $100 is way too high. So using a calculator, we could find which one of these two answers is correct. And if you do that and follow along, you'll find the answer to be $74.71. This little under $70 plus 6.75% of that gives us this amount here. Using the sales tax, we know it's going to be a slight increase. So for A, now we're talking about discounts, so something's going to go down. So a dog toy is on sale for 20% of the original price. 20% off of the original price, so we know it's going down. If the original price of the toy is $380, what's the discounted price? So we can find that with just a couple steps. So what is the discount? How much money are we saving? So 20% times our original tells us what the change is. 20% is a decimal, move it over, 1, 2 is just 0.2. 0.2 times 380 gives us 76 cents. So our decrease is 76 cents, that's our change, and we know it's going down. So now to find that final amount, we take our original, $3.80, and take away 76 cents. We do that subtraction and we get $3.04. That is our final amount with that discount. So the discounted price of the dog toy, $3.04. Just 2 steps. Okay, so 4B, one more discount problem to talk about. A baseball cap is on sale for 15% off of the original price. If the original price is $19.99, what is that discounted price? So we need to find out what is 15% or 0.15 of $19.99. $15% times our original will tell us how much it will go down. And then we'll have to take our original value, that $19.99, and subtract whatever this is, whatever this discount price is. So $19.99 minus the discount will give us that final price that we have to pay. So 0.15 times about $20. Let's think about what that would be. Well, if I imagine this is exactly 20, and we know it's not, it's a little bit under, but let's imagine this is 20 for the sake of multiplication. 20 times 0.15, what would that give us? So 5 times 0 is 0, 2 times 5 is 10, 1 times 0 is 0, and 1 times 2 is 2. This is 300, but we got 2 decimals, so this is just 3. So 15% of 20 would be $3 as a discount. So this is going to be a shade under $3 as a discount. So 20 bucks minus, we're estimating, 20 bucks, take away $3 would be $17. So which answer is almost exactly $17, just under it? Well, $9.99 is way off, way off, way off. We see our answer must be C, $16.99. We find our discount, and we subtract from the original, and that's how we get that value. So discount for this one, 15% off, gives us $16.99. So hopefully you feel confident with that as we move forward with some example problems.